small that we have to have very, very special microscopes in order to see them. Some of them are so small that they can infect each other. Like viruses infect bacteria. They're so small. So we named bacteria, I just named virus. Can you name another one? Anybody know another kind of microorganism? An example? Have any of you ever had athlete's foot? Athlete's foot is caused by, you know? Fungus! That's a microorganism. Now, microorganism funguses can divide to be seen. Can bacteria do that too? Some of you might have already had your lab. You can grow bacteria in a petri dish, right? You can see that. You're not seeing the individual cells. Home. All right, so microorganisms are organisms that are too small to be seen. With the naked eye, we have to have a microscope. We've got bacteria, we've got viruses, we've got fungus, protozoa. Protozoa are single-cell organisms. Maybe you've heard of amoeba. Have you ever heard of that, an amoeba? Yeah. So those are things that can infect us, very tiny things that can infect us. And then there's one you've not heard of probably, prion or prion. These are very unusual acellular agents. Acellular means, what is, you put an A before a word, what does that mean? Single, not quite, close. Not, A is like not a cell. Acellular, right? Okay. So we'll be doing that a little bit as we go through. When we come across some words, I'll tell you sort of, maybe what that prefix or that suffix means. Because in medicine, we use a lot of Latin stuff, and that helps us describe what we're doing, or describe a symptom, or describe a disease. So prion is an acellular agent. It's not a cell. It's a protein. A prion is just a protein that's not folded properly, because in order for proteins to work, they have to be folded in three-dimensional structures of a certain way. And a prion doesn't have the proper fold, and it can cause disease. And that is just freaky weird that can happen. Yeah. And so we'll talk more about that in the future. We're just doing our intro today. We'll talk about some diseases that are caused by these misfolded proteins. Okay. Have you ever heard of the microbiome? Have you ever heard of a biome? What about bio? What does the prefix bio mean?
Life.
Life. Biology. Biology of life. Biology studies of life. Okay. So microbiome would be microscopic life, right? Yeah. And iome just means like habitat. Where are they? Where they live in a certain area. So the human microbiome are all the organisms that live on us and in us. Trillions of them. We are all covered in microorganisms inside and out. And that's the microbiome. Now I'm old enough to remember that we didn't know anything about this when I was in school. We didn't even know about this really when I was in nursing school. Okay? This is really something that has happened in the 90s. So, the human microbiome, do you think it's good or bad?
Good.
Good? Good? Bad? Yeah. Okay, so for the most part, good. Could it occasionally, under certain circumstances, be bad? Yes. Okay? But for the most part, the human microbiome is really good because it helps us. So the organisms in us and on us can prevent disease. That sounds crazy because when we think of bacteria, we think of something that's going to make us sick. We want to wash that off. But we have these resident bacteria, they're in our body, they're our residents, in our body, on our skin, and they compete with the bad bacteria, and so they keep their numbers down. Yeah. So in our gut, same thing. So having a healthy microbiome is like really, really big stuff right now. Like, you know, have you ever heard of a probiotic? So probiotic, pro good, okay? So probiotic is marketed to help our microbiome stay healthy, generally the gut, yeah. There are, I don't go in for all those supplements because I'm going to tell you most of them are just nothing. Supplements are just big billion-dollar business. But I am into nutritional microbiomes like yogurt, kimchi, some of those kinds of things that we can eat, natural things that help improve our microbiome. So preventing disease, aiding digestion. And they do that by helping to not only digest the things we eat, but also keeping down the bad bacteria that might make us ill. They are very important in our immune function. And we're going to have a chapter or two about our immune system and how it responds to stress. And the microbiome helps that system stay healthy. Allergies. So when I was a kid growing up, we did not have any screens whatsoever. Well, that's not true. We did have TV. I'm not that old. But it was black and white while I was a little bitty kid. And so we did not stay inside much as kids. We stayed outside. And because that's where the stuff's happening, right? So I had two brothers, and we would go outside. They treated me like one of their one of their friends. They treated me like a boy, so I grew up, just being with my brothers, being one of the boys. And I played football and baseball and all of them, little boys, army, and all the little things the boys play. But we were outside. We were barefoot. We were in the dirt, in the grass, petting our dogs. You know what I'm saying? We were exposed to a whole lot of microorganisms in the environment. And we don't have any allergies, okay? So one of the things that our microbiome does is it helps us not be allergic to something. And an allergy occurs when something called an antigen, something we think is foreign, gets into our body and we react to that. So there's some evidence that our lifestyle, as we've gone from when I grew up in the 60s and 70s to being more inside. Kids are more inside more often. They're not playing outside as much. They're not going barefoot. They're not exposed to so many environmental things. And one of the theories is that the reason we have increased allergies is because we're not being exposed to the microorganisms in our exterior environment. So if you have kids, let them mess up. And then this is really wild. Can our gut microbiome affect our brain chemistry? Do I feel depressed because the microorganisms in my body aren't doing something right, or I don't have enough of them? Have you heard of this? Yeah. To me, this is just fascinating. I mean, are we controlling them, or are they controlling us, right? So microorganisms in our gut, when I say gut, I mean our large intestine really is what I mean. Small intestine, large intestine. They make serotonin. And serotonin is a neurotransmitter. And serotonin makes our mood more stable. So there is some evidence that if we have something going on in our microbiome that isn't good, and we're not making enough serotonin, that it can affect our brain chemistry. And the result of that will be, the effect of that will be depression or some other mood change. And I just find that fascinating. So maybe in the future, what we'll do to treat, it's generally depression, but it's a few other things too. But what we'll do to treat those brain disorders is fix our gut bacteria. So that'll be kind of interesting to see. All right. Sorry about that. Sometimes I can hit my remote control with a few bad things. Okay. So, all of this being said, in the world of microbiology, most microbes are not harmful to us. The vast majority are not harmful to us. But there are some that are, and those are called specifically pathogens. So you'll notice that when I put something in red, you'll probably see that on the quiz. Okay? So really pay attention to my red words in our slideshows. So pathogen is an important word for you to know. It causes disease. It causes a pathology. And a pathologist is somebody who studies that disease. So, for those of you going into some healthcare field, and it really should be almost all of you, where you'll be around people providing a service for them in some form, you have to respect the pathogen. Not only for your patients, your future patients, but also for you. Okay? Has anyone ever had anybody in their family, or even you yourself, go to the hospital and get an infection? Have you heard of that? People go into the hospital for surgery and they get an incision infection. People go into the hospital for some treatment and they get a diarrheal disease called C. diff. Or people go into the hospital, they get on a ventilator, and because they had COVID, so they're on a ventilator, and now they have a different kind of pneumonia that they got at the hospital. Have you heard of these things? Yeah. One of the ones that is everywhere is called MRSA, M-R-S-A, and it's a type of bacteria that is resistant to medication. So antibiotic-resistant bacteria. That occurs because bacteria evolve. They evolve and change. And so we'll talk about that as well as we go on. So you have to not get infected yourself, but you also can't transfer infection from patient to patient, right? So there's a lot of protocols that you're going to learn. And we'll talk about some of those. Aseptic technique, things like that. How to keep your patient safe, but also how to keep you safe. Yeah. So I had a friend, way long ago in the 80s. MRSA was just coming out in the late 80s, early 90s. It was really kind of bad. We were just learning about that. And she had gotten her ears pierced, and she got MRSA in her piercing of her ear because she got it from a patient that transferred it to her. You're in your patient's room doing something, and then you're doing this. And this was really before we wore as many gloves as we wear now. Yeah. Okay. So I really like a good graph. This graph, let's just kind of have a look at it. So the title says death rates per 100,000, infectious diseases per year in the U.S. So the title tells you what is given in the picture. So we're looking at the rate of death per 100,000, and then at the bottom is the year. Okay, so if we look at 1900, I got a new toy my husband gave me for Christmas. Look at this. So if we look at 1900 over here, then we can see that in 1900 there were about 775 deaths per 100,000 individuals. And these are infectious diseases. I'm not talking about dying from cancer, dying from heart disease. I'm talking about dying from pathogen. Okay? So at about 1900, we started having some health departments because we determined that this kind of community death, deaths in the community could be spread around, and we need to try to limit that. So that's what health departments do. So we got a big drop here. First, continuous municipal use of chlorine that time? Where were they coming from?
The water.
Contaminated water, right? Yeah, contaminated water sources. So now we're cleaning the water with chlorine, because chlorine is what's the active ingredient in bleach, and it kills everything. It's awesome. And it doesn't cause antibiotic resistance. Okay? It kills the pathogens in such a way that they don't evolve and become resistant to it. So it's a good thing. All right, so that really dropped. And then what happened here? Oh my gosh, look. So we had that influenza pandemic, remember in 1912, you've probably heard about that. So the flu can kill. The flu can kill. It killed thousands of people. All right, we got over the flu, and then we had the plague. Have you heard of that? The plague, it killed a whole bunch of people in Europe. Yeah, it's still around. It's bacteria we treated. It's not scary anymore because we can treat it. But back in the day, there was no treatment. People just died, laid on the streets, horrible. Lots and lots of people died. Like, I want to say 50% of Europe. I mean, it was a big deal. Yeah. Okay. Now we're getting into more modern times with penicillin. What's penicillin? What is penicillin? It's an antibiotic, right? It's a really old antibiotic. It's been around since 1940. It's really developed because soldiers were dying in the war. And so we developed a drug, probably heard about it, red fungus, Fleming, maybe this is, ringing bells, right? Penicillin is still used today. So that's, that's how important it is. We'll learn about how penicillin works later on. And then we get down here to vaccine. First, polio vaccine introduced, Vaccine Assistance Act. So now, okay. This is me. I'm in here, right? This is I was a little child in the 60s and a teenager in the 70s. So, vaccines really were just being given to kids, during that time. And some of the vaccines you have had, I haven't had. I had the disease, like chickenpox. I had the chickenpox. I was sick. My mother said I was sickest that I've ever been in my whole life. My older brother brought them home. I was 2 years old. I had the pox from the soles of my feet to my scalp, inside my mouth and throat. I was so sick. Chickenpox is a very, very dangerous virus. You guys may have had chickenpox if you're born before, I should say, maybe 1990. Keep it going. Always remind me. I have to say a little bit about vaccines. I am 100% pro-vaccine. Okay? You're just not going to convince me that vaccines are bad. They just aren't. I've lived long enough to see what they can do. I've traveled all over the world. I've been to places that have no health care. I have taken care of children who were blind because they had measles, and now they're blind. Yeah. So they don't have a vaccine because it's an impoverished area of the world at the time. So vaccines are good. Okay? They really are good. Are they a little bit scary? They can be. I'm not going to lie about that. Polio? Okay, so polio was a dreadful disease. We'll talk more about it when we get to that chapter. It was a dreadful disease. Mothers were afraid for their kids to even go outside. Kids could be paralyzed, their breathing, and they were put into these contraptions, negative pressure tubes called iron lungs that changed the air pressure so that it would force them to take air into their lungs, and they would stay there and live there until they died. It was terrifying. Lots of kids were crippled because their muscles would stop working. So it was a dreadful, scary disease. I remember being a tiny little child going to a school and getting a little sugar cube with the polio vaccine on it. And we thought it was a miracle because it hasn't been eradicated, but it's really declined. However, the scary part of that vaccine, when I had one child, and when he was an infant, I had to determine if he was going to get his vaccines, right? And the polio vaccine scared me because at the time it was a live virus. So what I was giving my child was a weakened form of polio. And so that's what's scary. It's like, well, will they get something? Could they get, could they have polio? There is a small risk of that. But I decided to go ahead. I decided that the risk of not getting the vaccine and getting polio was greater than the risk of the vaccine. So vaccines are not without risk, but the advantage of them far outweighs the risk. Okay, and we'll talk more about that later. Okay. So, why is there less infection now? Think about that graph and what we just looked at. Why? Okay, so let me just stop for just a second. Years ago, 100 years ago, maybe 125 years ago, let's say 1900, the average lifespan of somebody in America was like 45 years old. 45 years old. Okay, I'd have been long gone if I lived in 1900. Now, the lifespan of an American is about 78, 79. It used to be a little bit higher and then it kind of dropped down a little bit because we had a pandemic and that changed the numbers a little bit. So why is it that people are living almost twice as long now than they were back in 1900? What do you think? What's changed?
Vaccination.
I got to get closer to you.
Oh, the vaccination.
Vaccines. Vaccines is a big one. Absolutely. People aren't dying from polio, influenza, those kinds of things. What else?
Advancement of healthcare.
See, I got to get closer.
The advancement of healthcare in general.
So healthcare has really changed, right? One of the things is antibiotics. People died. People, got an infection in their foot. It got in their bloodstream and they died because there were no antibiotics. Yeah. So, good. What else happened? Remember that water?
Science, we discovered new things.
Absolutely. Our knowledge has really increased because now we know in 1900 we really didn't, there was some talk about microorganisms, but we didn't know, right? Now we know. We know more what causes the diseases, and so when we know what causes it, we can work on a solution to treat or cure that disease. What about sanitation, right? Our water is cleaner. I know some of you have traveled. Maybe some of you have been to places where there's no running water. Have any of you been to those places? Well, there are, I can just assure you, there are places in this world where people have no running water and no electricity. Still, in 2025, they're getting fewer and fewer, but there are still places that are so impoverished. And you know what the lifespan in those places are? 45. Yeah. So, that's a bad thing. We need to do better with that. Yeah. Okay. So, I think you all said, modern sanitation, vaccination, antibiotics. I love the knowledge. That's a great one. So, that is why there's just so much less infection now. Okay, so this is nothing to write down. This is just right now, and I'm going to put something up here to show you what's happening right now. This is December 5th, 2024. You might have heard about this. There was an outbreak of listeria. So listeria is a bacteria that infects meat, specifically things like lunch meat, deli meat, that kind of thing. It can affect other things, but in this case, you can tell it was ready-to-eat meat poultry products. So you're thinking, oh well, big deal, but look, 2 people died. 8 cases, 17 hospitalizations, 2 deaths. Can you imagine, eating a deli mechanism in the United States to sort of announce and figure out these diseases, and it's called the CDC, the Center for Disease Control. So every now and then I'll see a headline, and I'll go to the CDC and see what they're saying about it, and I'll put it up here for us to talk about. And the remedy for this is you've heard of recalls. They'll put out a notice and say, oh, if you have this brand of lettuce salad kit in your refrigerator, throw it out, it's been contaminated, right? Have you heard of that, right? There was like E. coli in onions in the Big Mac just recently, in the fall, at McDonald's. Remember that? Huh. Okay, well, I'm gonna tell you about it. If y'all aren't remembering it and paying attention to it, I'm gonna be telling you about it. Okay, here's another one, polio. We just talked about that, right? So, polio, this is the last 12 months, so this is 2024, polio. We're having a bit of an increase in polio. It does mostly seem to be in Africa, but anywhere red, they have had some cases of polio. This is a surge in polio in the world. And so, why is that happening? Lack of vaccination, right? So, we're not going to just look at U.S. issues, we're going to also look at the world. Because some of you have ancestors that came from other parts of the world. I do. Do you have ancestors that came from somewhere else than here? Most of us have. Right? Yeah. Okay. Emerging infectious disease. What does that sound like? Emerging. Spreading? Yeah. So emerging infectious diseases are diseases that are occurring, either more of them, more numbers, or they're spreading to other places, or they're new, like it's just come up. We just had one that was new called COVID, SARS-CoV-2, right? Yeah. Okay, so those are emerging diseases. They're newly recognized diseases like SARS-CoV-2. They might be recent in appearance. In other words, we had this disease like history of it, and now it's coming back again. Okay. It might be just, it's so rare, we never see it, but oh, suddenly we're seeing more of it. Or it might usually be right here in this part of the world, but now it's spreading to other parts of the world. And those are all diseases that we would call emerging diseases. This is a really big deal. I know you're thinking, I live here in Tennessee or Memphis or Mid-South or the United States. I live here and I don't really need to know about this, but you do. Because we are not so small, the world, right? The world is really not tiny anymore. With air travel, we can go anywhere we want. And we can live and work there, we can come back, we can visit, we can have people visit us from other places. And so that's how diseases track around the world. Because we're very mobile. Here are just some of the diseases. You don't have to write these down. I just want you to have an understanding of these emerging diseases. We're going to talk about quite a few of these. So, as we look at this diagram, like I said, I love graphs, charts. I like putting information in a picture. So, as we look at these, we see wildlife, livestock, humans. So, many of these diseases come from animals. They start in livestock, wildlife, and then they mutate in a way that they can infect humans, and we can become infected. And so, have you heard of Lyme disease? How do you get Lyme disease? What carries it? Ticks. Yeah. The tick is not the cause, but the tick carries the bacteria that is the cause. And so, if you get bit by a tick with Lyme disease, there's the possibility their disease, it belonged to them. It mutated, and now it can infect people. So it's like a chicken pox. And chicken pox came from. Yeah. Okay. Ebola. You've heard of Ebola? There are other Ebola-like diseases that are hemorrhagic fevers. They're in the animals, and sometimes they jump into humans. And so pockets of infection will occur. Okay. And then just to give you an idea how worldwide this is, it's just showing you the different countries in the world and the emerging diseases that have occurred. And I know 1970 seems like a long time ago, but really in the world's history, it's really not that long ago. Yeah. And so in 1970, we had mpox, see that? And we just had a big deal about it last year. Okay. Again, so these diseases emerge, they die down, they kind of stay kind of low, off the radar, then they pop back up, and we start talking about them again. There's a bunch out there. Oh, here's one. Marburg. So this is a hemorrhagic fever similar to Ebola. And it says possible Marburg outbreak in Tanzania. Tanzania is a country in Africa. And it's not possible anymore. I just read yesterday that it's been confirmed that there's an outbreak of Marburg. So right now, there are no cases in America, but could you imagine how somebody could bring it to America? Absolutely. Yeah. And so that's why we have to be aware of these diseases as they pop up in the world, because we don't live in isolation anymore. So, emerging diseases occur because disease agents evolve. So can a virus evolve? Absolutely. That's why we have to get so many of those COVID boosters. It's really not because the vaccine isn't any good. It's because that stinking virus is so tricky. You know? So we have a vaccine and it gets rid of it. And what does that virus do? Changes to something. Just a little bit of change. And now that vaccine doesn't get rid of it. So we have to make a new vaccine to get rid of it. Part of that is our difficulty in making vaccines. So the goal is to find a vaccine, create a vaccine that will affect part of the COVID virus that doesn't mutate. Right? Yeah. Then you got one shot and it's good. And there, so not every part of the virus mutates, but right now, with our technology and our knowledge now, where the problem is that we haven't figured out what it is about that virus that's not going to change that we can get rid of, right? But hey, science, right? Yeah, what's your name?
Alex.
Ellie?
Alex.
Alex. Okay. So, as Alex said, I'm going to learn some of your names, but not all of them, because there's one of me and maybe of you. I would love to know all your names, though, but it's not going to happen. I'm just going to tell you. But as Alex said earlier, we learn, and that science builds and builds and builds, and we get better. do you think that is? Money, 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 right? I can develop a drug, a weight loss drug, and make billions of dollars from that weight loss drug, and I'm gonna make not billions of dollars from an antibiotic. I'm not gonna mess with it. So drug companies aren't interested in finding new antibiotics because of money. This is a big deal. This is terrible. Because what happens if we get to the point where we have 25 different pathogenic bacteria that infect us and nothing to kill us? Yeah. So there are people working on this, trying to help with this. Universities generally, because they're not as interested in money as companies are, you know. It's a big deal. And you will in your career, no matter what you're doing, but especially if you're a nurse, you will come into contact with people that are infected with pathogens that antibiotics won't kill. Okay? You need to be very careful with them, right? Careful for you, but also careful for all the other patients that you care for. SARS-CoV-2, we've already talked about that, how it mutates. And then changes in our society. 100 years ago, we didn't have to worry at all about what emerged in some other part of the world. It wasn't going to come here because our travel was so rare. But now we're very mobile. We love going places, we can afford to go to places now. While we can have those amazing adventures in those other countries, we can become infected. We can bring those diseases back to the United States or wherever. And then here's another thing: expansion into rural areas. So I live not very far from here. I live about a mile from this campus. 100 years ago, where I live was a field. Yeah. So now it's a city, right? So moving to rural areas, what's happening? What do we do as we move into rural areas? What are we getting rid of? Yeah, the habitat in that area, right? Yeah. So we're getting rid of the natural habitats, the biomes of those creatures. We're moving in to those areas, and we're disrupting the balance in that area. So maybe now we are living closer to bats, which carry a lot of viruses, but they themselves don't get infected with those viruses. But they're a mammal. They carry them, and a lot of those viruses can infect humans. Okay. So moving into rural areas, and then not getting vaccinated, which is what's going on right now. Right now, going on in most of Africa with polio. Remember that map I showed you. So we just have to be respectful as we develop and move into rural areas. Be respectful of those areas. Okay. You heard of this? Bird flu. Tell me you've heard of bird flu. Yeah. Yay! Okay. Actually, a lot of flu comes from birds. So we have influenza A and influenza B, and every influenza A came from a bird first. Okay? So these are avian viruses that mutate to become infecting to humans. So right now, H5N1 is the bird flu we're talking about. There are other H5 bird flus that do affect us. We have vaccines against them. But the flu we're talking about now, that's everywhere, that you hear about on the news, and cows, and the unpasteurized milk, and the poultry, that's all H5N1. It can affect, it is infecting lots of people. Okay? Not people, lots of creatures, not people, lots of creatures. Right now, there is no human-to-human transmission. So without human human to human transmission, to be infected, you have to be around an infected animal. So the people getting infected are poultry workers and dairy farmers. Okay, but I'm going to tell you, we do something called wastewater treatment testing. It's wastewater testing, and it is in wastewater all over the United States. This virus is being picked up. So while these things, like your cat can get infected, could you get it from your cat? Quite possibly. Okay? Yeah, so right now, human to human transmission isn't occurring, but people have been infected with it because they got it from the animals that they work with. Okay. Should we be concerned about bird flu? What do you think? No answer's a wrong answer. What do you think? What do you think?
Yes.
What's your name?
Mark.
Marcus. Yes. Okay. Can you tell me why?
Because it will eventually evolve and possibly could transfer.
Yes. That is perfect. So what he said was, we should be concerned about it because it could possibly evolve to have human to human transmission. Right? If we get human to human transmission of bird flu, it could be another pandemic. Yeah. So it is something that we need to be concerned about. It is something that we need to be careful about, pay attention to, keep up on. Should we even be developing human vaccines for bird flu? Do you think we should do that? Yes, we should do that. And we are thankfully doing that. We have a vaccine for animals. There's an H5N1 vaccine for animals. Chickens, cattle, the big carriers. Because here's the deal too. I'm a poultry farmer. Do I want my poultry to die? No, that's my livelihood. I want them to live, right? I want them to live to lay the eggs to sell to the people, right? Yeah. So I'm going to inoculate or give a vaccine to all my chickens. Okay. So, but there are animal vaccines for pigs or cows. Not everything has been inoculated. Has anybody died from bird flu? No. We've had 2 people die. One, I think, was in Canada. One was in Louisiana. That's not even that far from here. Yeah. Okay, so there are people that have caught bird flu from animal sources and died. There have been a lot of people that have caught it. But the fear is that the virus will mutate. It will become infectious to humans in such a way that we can pass it to each other, and it could be serious and we don't know. So that's the big fear. So don't be afraid. Do not be afraid. But you know what? If you see a dead bird, like leave alone. You know what I'm saying? Yeah. Be careful. Be aware. Keep up with the news. See what's going on with the bird. Okay. HAI. This is a big one. This is a big deal right now. Okay. Hospital or healthcare acquired infections. These are a big deal. These infections generally are bacterial. And they are way more common than you might think. So a hospital-acquired infection is just exactly what the word says, or healthcare-acquired infection is exactly what it says. It's an infection that you get when you're getting health care. One of the reasons this occurs is because of those antibacterial strains of, antibiotic-resistant strains of bacteria. One of the reasons is because some of the bacteria can produce something that we're going to learn about called endospore, which can't be killed, but it can infect. That's one of the reasons. off. Because let me tell you something. Every single day, you're fighting something off, aren't you? You're exposed to pathogens constantly. But you don't get sick because your healthy immune system gets rid of them. Have you ever, though, been stressed out? Like, just so stressed out over whatever, I don't know, but just so stressed out. Stuff's going on in your life, and that's when you get a cold? Have you noticed that? Yeah, because that stress decreases your immune system. It decreases your ability to fight off an infection. I would say going into a hospital is a very stress-provoking situation, isn't it? Yeah. So we have to be so careful. Our patients are already at a low point in their immune system and can get stuff so easy. And that's another reason why we get it easy. Okay, so 2 words, red words, we're going to define these in a minute. HAIs. Well, we love just shortening everything in medicine. Everything's just shortened, you know. So HAIs are very serious, and they can cause morbidity and mortality. So you know what those words mean. What is mortality? Death? Death? I think I heard somebody maybe said that. Mort. So it was Latin death. So mortality. Morbidity is just illness. So morbidity is a disease. Mortality is death. The worst feeling in the world is taking care of a patient who gets a hospital-acquired infection and then they die. That's terrible. Because our goal as healthcare providers is the opposite of that, isn't it? Yeah, our goal as a healthcare provider is to help that patient overcome that illness and go home. Yeah. But it happens. And if they don't die, they can have morbidity, they can have disease, they can have something, maybe they get over the infection, but now their heart is weakened from that infection. Okay, we'll talk more about some of this stuff later. Hey, do you like case studies? Do you know what I'm talking about with a case study? Yeah. So I like case studies where I just kind of give you the case and ask you your questions about it. Most of them are very easy questions, but we'll have some case studies as we go throughout the course. We'll have some just as like little 5-point assignments just to get used to them. We'll have some on but here's a case study. Get back here. We'll read through this. So a 55-year-old white female presented to the emergency department with severe chest pain. She was diagnosed with an ascending aortic aneurysm. That sounds bad, doesn't it? So let me tell you what that is. An aneurysm is a bulging, okay, something like a weakness in the wall of an artery. And the artery we're talking about is a big artery, it's big as a quarter that goes from your heart and down through your chest and into your abdomen. If you've ever felt the pulse at your belly button, that is your abdominal aortic or aorta pulsing, beating. Okay? Some of you have already had your anatomy, so you can do all that. Okay, during the procedure, she went to the cath lab. Cath lab is just lab in the hospital. During the procedure, the patient had sudden cardiac arrest. What's that? She died. Sudden cardiac arrest, she died. She died on the table. Okay, that's what that is. Her heart stopped beating properly. A cannula, that's just a tube, fancy word for a tube, was placed in her heart, and ECMO. ECMO is a machine that beats her heart when the heart can't beat on its own. Okay? Was used. Okay. 5 days later, the patient was feverish and confused, and she was diagnosed with acute septic shock. So acute means sudden, septic shock means I have an infection in my entire body. Pseudomonas, that's just the name of a pathogen, was cultured at the entry point for the ECMO cannula. And this is probably stuff isn't relevant, right, to your answer. But this is important. Pseudomonas was cultured at the entry point for the ECMO cannula. The patient survived but spent 61 days in the hospital for something that should not have been that long. So my question to you is, what do you think could have, what's a possible scenario that could have happened to have caused this problem in this patient? Is that right? Okay. So he said the ECMO, the cannula, right, the tube that was put in her body wasn't sanitized or was even contaminated, right? That's the statement, right? So what happened was something happened at that point of the cannula. Either the cannula was not clean and free of disease, or the skin was not properly prepared and she had Pseudomonas on her skin that went into her body, right? Well, this is a true story. And they did a review, you know, like what happened, right? They want to know what happened. What happened was, when somebody goes into cardiac arrest, it is not like on TV. It is chaos, okay? It's a big deal. And people, all of a sudden, there's a lot of people in the room, and there's a lot going on all the time, very busy. People are doing, let me just say it's organized chaos. People know their job and they're doing their job, but there's a lot going on. Somebody had that cannula in her hand and sat it down. And then it was grabbed and put into the patient. And it had become contaminated when it was sat down. So that's a big mistake. Absolutely a big mistake. But in the situation, if she'd just been having that cannula placed without cardiac arrest, it would have been fine. This would have happened. Yeah. Okay. Chronic disease, we'll talk a lot more about that, but there are there are pathogen-related chronic diseases. So a chronic disease, anybody know what that is? Chronic disease? Well, there could be, yeah, there's no cure or there's treatment for no cure. And it's longer lasting. Right? So a chronic disease example would be diabetes. Right now there's no cure for diabetes. There's a lot of great treatment for diabetes. So it's a disease that you have for a long period of time. That's chronic. So can you imagine we have bacteria that cause chronic disease? Isn't that crazy? Yeah. One of them is stomach ulcers. So when I was in nursing school, stomach ulcers were caused by stress or diet. And then later, after I got out of nursing school, we learned that stomach ulcers are caused by bacteria called Helicobacter pylori, or H. pylori. This is a very common bacteria. Probably about 80% of all people are infected with it. We carry it around in our stomach. I'm sure I have it. We carry it around in our stomach. It can survive our stomach acid, which is, pretty remarkable. And if our microbiome gets out of whack, it can begin to overgrow and cause ulcerations, or, have you ever had a mouth ulcer? Have you ever had that, that mouth ulcer? Yeah. So your lining of your esophagus, your stomach, and your intestines is all the same. It's that because of the two mouths, it's just like that. Okay? So it's like getting a mouth ulcer in your stomach. Another one is cancer. Viral causes of cancer. One of the biggest ones is cervical cancer. So we have a vaccine for HPV. Guess what? If you get the HPV vaccine, you don't get cervical cancer. Rates of cervical cancer have gone almost to zero. Not everybody's vaccinated. Isn't that amazing? Yeah. So disease caused by bacteria from my mouth. So we are learning so much more about how some of these chronic diseases are caused by infectious diseases. So we can't focus just on chronic disease. We have to also really look at these infectious diseases because in many cases they're the underlying cause of our chronic diseases. Even to the point of some of our autoimmune disorders. Autoimmune disorders are when your body sees your own cells, they're called self cells, as foreign, and begins to fight them off. Okay, that's not good, right? Rheumatoid arthritis, some forms of diabetes, lupus, irritable bowel disorders, there's just the whole list of autoimmune disorders. Okay? How do autoimmune disorders start? Bacteria. They start with bacteria and then the body having a big response to that bacteria instead of a normal response. And it begins to, in the case of rheumatoid arthritis, you have cartilage between your joints and your body begins to destroy the cartilage between your joints. That's not good. Bacterial cause for that, isn't that crazy? Yeah. So we're really learning a lot. Okay. Hey, we got some time left to really talk about a few other things. So, you already know most of this. You had it in probably middle school, but we're just going to review it all so everybody is on the same page. So, we've got a couple of types of cells. Prokaryotic cells. These cells don't have a nucleus, membrane nucleus, and they don't have other sort of membrane-bound organelles. So a prokaryotic cell is not like that normal cell diagram that you see in a textbook with all the parts, cut the cell in half and you see all those little parts in there. Like, you remember this? Like, the mitochondria. And is this coming back to you a little bit? The Golgi apparatus and the endoplasmic reticulum. Yeah, we're not going to learn about that. Okay? We don't need to know about that stuff. I'm not saying it's not good for that. We need to know about the effects of bacteria and viruses. Okay, eukaryotic cells, they do have the nucleus. They do have those organelles that I just named. Ribosomes are actually in both, but they don't need that. So prokaryotic cells, eukaryotic cells, two types of cells. This is called taxonomy, or it's called like the domains of life. Do you remember all that? Yeah, animal kingdom. Yeah, you remember that. Okay, so these are just two domains. Prokaryotic and eukaryotic. So bacteria, prokaryotic. Archaea, prokaryotic. So these are our three domains that we're going to be talking about in this class. Eukarya, eukaryotic or eukaryotes. So a question I could ask you about this would be, which domain of these three domains have a nucleus with a membrane and membrane-bound organelles? And your answer would be?
Eukaryote.
Eukarya. Okay. So just facts about how we like to label things, put things in order so that we can understand them better and so that we can communicate those things better. Okay. Oh yay, I love another chart here. Here's the thing. Some people, I think, love words and they get it with words, but I think sometimes people see picture and it helps them out a little bit. So the microbial world at the top, and then organisms on the left side of this versus acellular infectious agents, things that are not cells, right? Okay. So there's just three of those. But on the left side, we've got our three domains: bacteria, archaea, and eukarya. We've got prokaryotes, unicellular, and eukaryotes. Now, in the eukaryotes, we're going to talk about not only fungi, we're going to talk about helminths. We're going to talk about those, even though they themselves, you can see, they're not microorganisms, they're worms. But their eggs are often microscopic. And then protist. The protist is just the name for the algae and the protozoa together. Okay. So these are just some of the things we're going to talk about. And then, I'm going to go back. And then this is from the book. If we look at this gives you some pretty good information in a chart form. So we've got our domains at the top, bacteria, archaea, eukarya, and then just some information about this. Telling you cell type, you already know, number of cells, unicellular, cellular, multicellular, membrane bound organelles. These are just things I just told you about. Ribosomes are in both, in all of it. And then what I really want you to just look at this word. We're going to talk a lot more about this word this week and next week, right here. Peptidoglycan, right? It's a weird word, peptidoglycan. It's a chemical, a substance that is found in the cell walls of bacteria. Notice it's not in archaea, and it's not in eukarya, and it's not in every single bacteria, but most bacteria. Peptidoglycan. Okay. So, shapes of the bacteria that you're going to be seeing under the microscope have names. We use those names to help us describe the shape that we see under that microscope, and they're kind of like universal names. So everybody knows coccus or cocci is a spherical. It looks round under a microscope, but it's actually a three-dimensional sphere. Bacilli is just one. Bacillus is the group of them. They are rod-shaped. Vibrio, they're short, they're really short, they're always curved. They're a little rod-shaped, but they kind of look like commas. Okay? Yeah. Not too many Vibrio infect humans. Spirillum tells you the name, doesn't it? Does it sound like spiral? Spirillum? Spiral? So these are going to be rods that form spirals. A spiral sheet is just kind of like a spirillum, but it's long. A long spiral shape. And then there's one for like, okay, we don't know, they changed shape. Pleomorphic. We're not going to do but you know, we have to have a category for those exceptions, right? Pleomorphic is that category. We're going to really look at coccus, bacillus, and maybe a spiral shaped as well. Because we're not looking at what infects animals or plants, we're looking at what infects humans. Okay, so if we were to look at these, just to kind of give you drawing versus a photograph, a micrograph of what these look like. Some of you have had your lab and you've seen these. Some of you are going to be taking lab and you will see these under the microscope. So we're going to spend Thursday and probably next Tuesday really going over some things that will help you in your lab. And also give you some background for understanding what a lab report tells you once you get, into your career. You'll be reading lab reports, so you should know some of these things. Okay, and then we also, bacteria are cell and bone cells, like blood bacteria. Like, okay, if you got infected with one bacteria, if you got infected with one bacteria, would you get sick? No, you wouldn't get sick. Infection is pretty much dose related, which means the more you have, the more chances are you are getting sick. There are some diseases where you just think if you like 10 or 12, and you can get sick from that. But one, you're gonna fight that off. Okay? So most bacteria exist as groups. So die means two. Yeah. So you already know from that word alone what it is. Die. Two. Cockeye, what's that? What shape? Yes, spherical. So you already know two spheres, right? Pairs of cocci. Long chains, streptococcus. Strept, that prefix means a chain. Strept. Okay? So coccus would be round or spherical bacteria in chains. What if I said it was streptobacillus? Chains of rods. Chains of rods. Clusters of cocci is staff. Staff means a cluster. Like a grape. You know, like clusters of grapes. And you know, you might get a lab report that says Staphylococcus was found in the urine. And you would know, oh, well, that's going to be round bacteria, groups or clumps of them. Yeah, and there are certain medications that are good for those, right? So basically, the name that we give to the bacterial species will often tell us a description of that species in some form or fashion. And just some pictures, just drawings, photographs, to just kind of show you. Packets and clusters differ a little bit because you see how a packet is more organized, you know, where a cluster is more random. But all of that is going to be staff. The bottom two. Okay, archaea. Archaea are insane. Okay. They are very similar to bacteria, as you can see up there. They're similar in size. They don't have a membrane-bound nucleus. They're single cells. And I'm going to tell you, we don't know a lot about them. They are a big area of study. We call them extremophile. When you hear the word extremophile, what comes to mind? Extremophile. A lot. So say that one more time.
The extreme.
Yeah, like extreme, like a lot of it. Yeah, like it's something that's extreme. Like, man, that's extreme. Right? When we say that, yeah, that's extreme. So extremophile means that they can live in very extreme kind of conditions. Like outrageous places. Like, 200 feet below the ice of the Arctic. Really? Yes. Really. Okay, so extremophiles. So they can live in hot thermal vents under the ocean, and heat kills most everything. Okay? You're going to learn that pathogenic bacteria don't want to grow in much above your normal body temperature. That's why when you get sick, you get a fever. Yeah. When you get sick, you run a fever because your body says, I want to kill this. And that bacteria has a very, very limited range of temperature to live in. And that fever, just a few degrees above normal, burns that bacteria up. It's crazy, isn't it? But these guys, they can live in extreme places. So one of the most extreme places is the acid of your stomach. We didn't know that archaea lived on us until the last probably 5 years. We thought, oh, they live in really salty places. Oh, they live in really acidic conditions in the world, but not in us. But we now know that they do live in us. We don't know if they cause any disease. We don't know. So what about bacteria that thrive in warm conditions? Yeah, there are bacteria that thrive in warm conditions. They usually don't